All right, welcome. So again, we're doing compound and simple interest today, and we're going to start with simple. All right, right here we already actually have the definition of simple interest written down. The interest earned at the end of each year is a percent of the original deposited amount. Now, that might seem a little weird. Let's talk about what interest means. Interest is kind of the extra money that you earn that the bank rewards you with for keeping your money in a bank. So interest gets tacked on at the end, and it's just that bonus amount that you get depending on how much you put in. So the more you put in, the more interest you earn, and that's part of it. So we're going to go through an example together, and then we're going to try some by yourself and that sort of idea. So again, we're doing simple first. So suppose that Wally deposits $1,000 into an account. So he has $1,000 and it earns 5% simple interest each year. Okay? So our initial amount is $1,000 because that's how much he has right now. And then it's 5%. That's our interest each year is 5%. So we're just going to put 5% here. Now, here's the part that you have to do a little bit of math for. You are not allowed to use 5% when you do formulas or do testing or anything like that. You have to change it to a decimal. Now, there's two ways to do that. You can do 5 divided by 100 and get 0.05. Or if you just have a 5, you can move that decimal place to, then you have 0.05. So again, that's the number that we're going to use when we do this. Okay, so we need to figure out what 5% of 1,000 is. Okay, so to do that, you just need to multiply. So over here, we're just going to do it on the side here. We'll do 1,000 times 0.05. Try it out on your calculator. Make sure you're typing everything in right. And you should get 50. So that means each year you get $50 extra money. $50 interest goes into your account. So let's start filling out this table here. If I keep it in for 0 years, I don't earn any money. All right, so they don't give me money if you don't keep it in for a year. So 0 for right there. So that means what I have right now, my initial amount is just 1,000. No bonus money. But after 1 year, I get to add $50 to it. So I do 1,000 plus 50, and it's 1,050. That looks like a 0 there. All right. And again, second year, you earn another extra $50. So you have $1,100. And so forth and so on like that. Again, another 50. I add it to this amount. Another 50. And I keep adding it, so now we have $1,200. So without even adding any money in, and you keep it in there for 4 years, you made an extra $200. Another 50, so we're left with $1,250. Okay, so now we need to think about this. What type of sequence does the account balance represent? So remember our two sequences, arithmetic and geometric. Arithmetic is when we add the same amount each time, and geometric is when we multiply it each time. So when we had 1,000, we added 50 to it. All of these are increasing by 50. So plus 50. Between these two, plus 50. And so forth like that, plus 50. So that would make this an arithmetic sequence. Okay. And now we need to figure out what the common difference or ratio is. Well, remember, when it's arithmetic, it's difference, so it's just D equals 50. And that's all there is to it. So let me show you this actual formula that's used instead of having to do all this. So think about it. When we had 5 years, I couldn't go right from 0 to 5 years. I had to find all the ones in between. So now there's a formula that actually helps us find right away just 5 years. And here's your formula. So write this down in it and include all the arrows too. So we have P of T. This is your amount after T years. Okay, so I want to know after 10 years, after 20 years. P sub 0 is your initial deposit, and that goes here n right here. And then it's p sub 0 plus, and then notice the parenthesis, p sub 0 times r. And now notice the special thing about r, it's rate as a decimal. Again, you can't put an actual percent sign in there, you have to change it to a decimal. And then all of that is times t, times your time in years. Notice again, it's years, okay? If you have months, you have to change it to years. So let's do an actual problem here. Okay, so I'm just going to rewrite the formula because we don't have it out in front of you. So it's P of t equals P sub 0 plus parenthesis P sub 0 times r and all of that times t. Now here's our new function. It says we need to write Wally's account balance after 8 years. Well, I don't want to have to fill in the table, so I want to use the formula. So I'm going to substitute what we know in. We know 1,000 is my P sub 0, that's my initial amount, and I know my rate is 0.05. So we're going to have 1,000 plus 1,000 times my 0.05 all times my t. I'm just going to write a simple formula right now. Now all I can simplify is the parentheses. I don't want to add it, I want to just multiply these two, and that's what we just did on the previous page. 1,000 times 0.05 is just 50. So it's 1,000 plus 50 t. Now if we read our first one, use the function to determine Wally's account balance after 8 years. So that's my t. So I'm going to have 1,000 plus 50, but instead of t, I'm going to put 8. And then I just type that in the calculator. I'm not trying to trick you, I'm not trying to do anything like that. Just type it in the calculator and you end up getting $1,400. And that's that. Now we're going to do the same thing, but notice this one is 100 years. So now I'm going to substitute 100 in for t. So 1,000 plus 50 times 100. And again, you just type that all in the calculator. There's no x to solve for, nothing like that. And you get $6,000. All right, now we're going to do it a little backwards. Now it says use the function to determine how long it will take for Waldo's account balance to reach 1,600. Okay, so now I want to know how many years, what my t value is if I know my answer already. So now I know my answer is 1,600. So I'm going to rewrite my formula, but include t this time, and I'm going to have 1,000 plus 50t equals 1,600. And look, guess what it is? Two-step equation. So I got a little crooked there. Minus 1,000 so I get 600 over here. These have crossed off. I'm left with 50t. Again, I'm going to go through this quickly because this is something that we have practiced a bunch. So we have 50t equals 600. We're going to divide by 50 on both sides. Just going to rewrite it up here. T equals, if I divide by 50, divide by 50, remember those t's or those 50s then will cancel each other out. And 600 divided by 50 is 12. 12 what? Years. All right, so now, how long for Waldo's account balance to double? Well, if it's doubling, and I started with 1,000, it's going to be 2,000. So I'm going to set my equation equal to 2,000. So 1,000 plus 50t, and then I'm going to subtract 1,000 on both sides. $50t equals 1,000. Divide by 50. Divide by 50. T equals 20 years. There we go. Okay, that next problem, you're actually going to do this one yourself, okay? So take some time, try that one yourself, and then when you're ready, come back and we're going to do compound interest. Okay, so compound interest, the definition is already up here. This one's a little bit different than simple. The interest earned at the end of the year is a percent of the account balance at the beginning. So it's not always on your initial amount now. Now it goes with whatever's in there. So the interest you earned last year earns you more interest for the next year. It's kind of cool where it just keeps changing like that. So again, now Mario deposits 1,000, so our initial deposit is 1,000. And he earns 5%, so remember that's 0.05. Compounded each year, okay? Now the same initial amount is always going to occur. You don't earn any interest if you don't keep it in there for a year. So we have 0 and we have 1,000. Now, what we do is we take what we have and we multiply it by 0.05. So it's just going to be 1,000 times 0.05. And that just gives me 50. Which is what we did in the last one. So the first two are going to be the same. 50 plus 1,000 is 1,050. Now, instead of these all being 50, I take my new amount, the new dollar amount that I have in my account, and I multiply that by 0.05. So I'm going to have 1050 times 0.05. And when you do that on the calculator, you get 52.50, which makes sense. If you have more money, then you earn more interest. So now I have $1,102.50. Now that's my new amount I get to multiply over here. We have $1,102, sorry, this is hard to write over here, times 0.05, and when you do that on the calculator, you get $55. And we're not going to round this just yet. It's 125 thousandths. So then you're going to add that to your new amount, because that's how much interest you earn. Again, the more money you have in the bank, the more interest you earn. So it's $1,157 and 1.125. And you see the pattern I'm kind of going with, right? So I'm going to multiply this number by 0.05. I'm not actually going to show my work anymore. It gets too much now. So we're going to multiply this by 105, and we get $57 and 88 cents. And when you round that, we get 1,215 point, and again I'm rounding now, 50 cents, because again cents are only 2 decimal places. Now I'm going to take my new money and I'm going to multiply it by 0.05, my interest amount, and I get $60.77. Then I add it, so I have $1,276.28. Now we need to think about what type of sequence this is. So what type of sequence is this? Think about it. We are not adding the same amount each time. One where we had plus 50, it's not plus 50 anymore. So that means I'm actually multiplying. So this is a geometric sequence. And my rate, here's where it gets a little interesting, I guess. My rate is 1.05, and let me explain why. Okay, I get the 0.05 from my compound interest, but remember, I'm not taking just 0.05. I have that initial amount. So I take my 1, it stands for 100. So I take my 100% of my money plus the 0.05. So that's why it's 1.05. Okay? All right. So now there's an actual formula, so I don't have to find all the ones in between, just like for simple. And you will not need to memorize these formulas, but you need to know how to use them. So again, it looks kind of the same because we have the same information. P of t, amount after t years, equals P sub 0, our initial amount. Notice this is now a times 1 plus our rate, and that's where I said the 1.05 in the previous problem, because you'd have to take how much you have right now and add something to it. And then it's to the power of t, so that's why I did this little caret sign, because you have to use the caret sign on your calculator and then put your years here. Okay, it's not times t, it's to the power of t. So let's do a problem together. Okay, so it says substitute the information from your problem situation into a formula and simplify. Okay, remember what we have. We have 1,000 as our initial and 0.05 as our rate. So we have P of t equals 1,000 times 1 plus my rate, all to the power of t. And see how I made it a little t? Now again, the only thing we can simplify is those parentheses. So it's going to be 1,000, 1.05 to the power of t. So now my time is the same as kind of the other one. We have 8 years, and that's my t. So I'm going to have 1,000 parentheses 1.05 to the power of 8. And now I just typed that in the calculator. Again, make sure you're typing it in, practice typing it in, because we haven't really done too many of these before. And you're only going to round to 2 decimal places because we're dealing with money. And yes, you should get decimals, not a big deal. $1,477.46. Kind of interesting. We did not earn that much when we had a simple interest account. So compound is a little more lucrative the more you have your money in the account. So now let's do 100 years. Let's see how high this one gets. So we have $1,000, 1.05 all to the 100th. And again, just type that in the calculator, round to 2 decimal places because we're dealing with money. It's 13,100, or whoa, 113. Hold on, let me just write it. There we go. 100. That's a big amount. So, $131,501.26. That is if you keep $1,000 in this bank for 100 years and don't touch it. That's how much money you'll have in it. Pretty exciting. Okay, so there are 2 more example problems after this. That's what you need to complete, and then you also need to complete your closure, and then we can give you your homework. I'm going to give you a little hint on this one. Can we look down here at question, I guess it's number 5 on your paper. It's Mercedes, and I highlighted these. Look at these. These are 6 months and 18 months. Think about what 6 months is for your calendar, okay? Your T, remember, has to be in years, so we can't substitute 6 in. If it's 6 months, that is half a year, right? So you're going to substitute in T equals 0.5. Now for 18 months, it's 1 year and 6 months. So it's 1 year and half. So your T is 1.5. Something to think about. This will occur on your test, so I'm giving you your hints now. But you need to remember that when you see months, you got to change it to years. And again, there'll be easy ones like this, like 6 months. Oh, well, that's half a year, right? That sort of idea. All right, so again, complete these problems, do your closure, and we can give you your homework, and we want to check it when you're done. Thank you.